Hello everybody and a very warm welcome to this session. Well, we are here to actually discuss about some important 5 questions which are primarily important for your JEE Advanced 2018 exam, which is scheduled to be held on 20th May 2018. Well, you all would be busy with the preparations, with the revision, with the practice of all the concepts in the entire syllabus, right? But one thing which students are very curious and anxious about this time for this particular paper of JEE Advanced on 20th May, which is going to be held, is about the online mode which is there for the exam this time. Completely online paper. Well, yes, it is a question to be becoming anxious about it because this time it is under the planning phase, but I can say one thing, that it can happen that the JEE team may set a subjective paper rather than completely an objective paper. Yes, you might not find all questions MCQ type. There might be some questions which demand you to type the short answers, okay, that is short type answer type questions, okay, which can make the paper look pretty subjective, right? So that's why an approach towards the paper needs to be altered a bit. Why? Because students which are just focusing on the MCQ type of questions, they are there with the option elimination technique, the guesswork, stuff like that. So they need to change their track a bit towards the preparation or the marking of the options or attempting the questions, right? So that is how you have to slightly alter your approach of preparation because you would be taking an online exam. Those people who have taken the JEE main online mode examination, you can just have a conversation with them and see that mathematics among all the 3 subjects, physics, chemistry and maths, mathematics happens to be pretty difficult when it comes to online attempting of questions. Okay, so just have a word with them and see what kind of difficulties did they confront while attempting their paper in the online mode. They thought of attempting 20 questions, but then actually they were just able to complete 15 questions of mathematics, right? So there is a hell lot of difference between sitting with a pen and paper and attempting a question in the online mode, okay? So if possible, practice some mock tests in your online mode, which can give you, a trailer of how the scene is going to be in your actual exam. Fine. This was about the online mode paper. Now moving on to the 5 important questions, or basically I should not say questions because you all know JEE Advanced paper is an unpredictable paper. Of course, the level is a notch higher than JEE mains, of course, but we cannot just vouch for the questions which are going to be there in the paper. But yes, there are certain concepts which can be vouched for to be there in the paper for JEE Advanced. And those concepts is what I would be stressing upon in today's session, which you are just not supposed to leave in your preparation of JEE Advanced. Okay? So moving on with the very first one, here you can see the very first question is coming from your chapter functions. Okay? One of the most conceptual chapters in the entire syllabus is functions. If I talk about the questions which are posed in the previous years, the concepts which are there involved in the JEE Advanced paper from the chapter functions were what? Composition of functions, periodicity of functions, then you had functional equations involved, inverse of a function, and you also had graphs of functions. Right. So among the 20-25 concepts which fall under the chapter functions, these are some 4-5 concepts which you have to have very, very strong grip upon. In 2015, there was question upon composition of functions and finding the domain and range. In 2016, there was a question upon finding the least or the minimum value of the function based upon inequality and again composition. Right? And 2017 had question based upon greatest integer function and functional equations. Now many a times you might not find these concepts of composition or inverse or periodicity directly asked in the questions, okay, but indirectly they can impose the same concepts from the application of derivative question or integration. They can do that and they have done that. So directly these concepts might not pop up in your paper, you might not just see them as it is in form of question, but yes, indirectly they will be there, that's a guarantee. Okay, so you have to have these 4-5 concepts completely in your pocket before you go to attempt the paper. Functions is that one chapter which if you do thoroughly, smoothly, very fluently, even if other chapters of calculus are not that good for you, you can end up cracking up many questions from the calculus section, at least attempting to a great level. So functions is something which you just cannot afford to leave in your preparation. Okay? Moving on to the question which I have here for you, you are given a function f of x which is sine of pi by 6 sine of pi by 2 sine x, you can see, for all x belonging to the collection of all reals. And gx is given to be pi by 2 sine x, again for all x belonging to the collection of all reals. They are talking about composition, FOG and GOF. And then the options say, find out the range of the function f, find out the range of the function FOG, then compute the limit f upon g and find out if there is an x such that GOF of x is 1 or not. So beginning with the very first point, which is computing the range of the function f. Well, over here, what is my f? F is given to be sine of pi by 6 sine of pi by 2 sine x, where x is coming from the collection of all reals. Okay? Now over here, you all are aware about the sine functions graph. Wherever x may come from the entire real line x may come from, sine x always ranges from -1 to 1. So as x is belonging to the collection of all reals, this implies sine x belongs to -1, 1 closed interval, something very basic here. Now I am going to use the intermediate value theorem because every function involved here is continuous, right? So if sine x is belonging in -1, 1 closed interval, this implies pi by 2 sine x is going to belong to minus pi by 2 closed interval. Yes? After that, moving ahead, sine of pi by 2 sine x. So if pi by 2 sine x is belonging here, again sine function is continuous. So this implies sine of pi by 2 sine x belongs to sine of minus pi by 2 comma sine of pi by 2, which is -1, 1. Right? After that, we move on to pi by 6 of this. So pi by 6 of sine of pi by 2 sine x belongs to minus pi by 6 comma plus pi by 6. Correct? And after that, sine of this thing. So if this argument is belonging in minus pi by 6 range, this means sine of this, sine of pi by 6, sine of pi by 2 sine x is going to belong to sine of minus pi by 6 comma sine of pi by 6 closed interval, which makes it -1 by 2, 1 by 2. And what is this? This is nothing but your f of x. So you have understood that whenever x is going to come from the collection of all reals, fx is going to land inside -1 by 2, 1 by 2 closed interval, which means that the range of the function f is -1 by 2, 1 by 2 closed interval. Moving on to FOG. Now see, carefully observe what is FOG. FOG is f of g of x. So it will be sine of pi by 6 sine of pi by 2 sine of pi by 2 sine x, right? Just in place of this x, I will have pi by 2 sine x. If I have to find the range of FOG, begin with this x, because this complete expression is sitting over here in place of this x. So when x is coming from the collection of all reals, sine x is landing inside -1, 1 closed interval. if sin x is landing inside minus 1, 1 closed interval, pi by 2 sin x will be inside minus pi by 2 closed interval. Now if this thing is in minus pi by 2 closed interval and it is sitting over here in place of x, that means now the argument is inside minus pi by 2 closed interval. So sine of this argument will be inside sine of minus pi by 2 comma sine of pi by 2 closed interval, which is minus 1, 1. Now if this thing completely is in minus 1, 1 closed interval, pi by 2 of this thing will be in minus pi by 2 closed interval. Now if this argument is in minus pi by 2 closed interval, sine of this argument will be in sine of minus pi by 2 sine of pi by 2 closed interval, which is again minus 1, 1. Minus 1, 1. So if this argument is now in minus 1, 1 closed interval, pi by 6 of it will be in minus pi by 6 closed interval. And if this complete argument is in minus pi by 6 closed interval, sine of it will be in sine of minus pi by 6 comma sine of pi by 6 closed interval, which makes it minus 1 by 2 closed interval again. Okay, so on the exact same lines, just what I said, if you write, you are going to land up with the conclusion that yes, range of FOG is also minus 1 by 2 closed interval. Okay. Moving on to the next one, which asks you to compute the limit f upon g. So computing the limit f upon g, let's see what all does it use. So you have limit x tends to 0, fx upon gx, which is what? Limit x tends to 0, your fx is sine of pi by 6 sine of pi by 2 sine x upon gx. Gx is just pi by 2 sine x. Now see, over here there is a direct hint towards a certain property which we do in limits and not in this chapter. But see how concepts get blended with each other and are asked in the same question. Over here, if I try to remind you, limit x tends to 0, sine x by x is 1. Remember this? We've done it in limits. So limit x tends to 0, sine x by x is 1 is basically trying to convey to you that when the argument of sine is sitting in the denominator as well and the argument is approaching to 0, then sine of that argument upon the same argument approaches to 1. Over here the argument that you can see is this, right? Now see, if x approaches 0, sin x approaches 0, sin x approaches 0, pi by 2 sin x approaches pi by 2 into 0, which is again 0. So if this thing approaches 0, sine of this thing again approaches to sine 0 because it is continuous, which is 0, and then pi by 6 of 0 is again 0. That means this argument is approaching to 0. So if I put the same argument in the denominator, I will be getting sine of this argument upon the same argument will approach to 1. But to divide this expression by this argument, I will have to multiply also by the same thing. So I can just modify this as sine of pi by 6 sine of pi by 2 sine x whole upon pi by 6 sine of pi by 2 sine x. Okay, so I've divided by the argument. Now I'm going to multiply by the argument. And what was there in the denominator is there. Right? Now you can carefully see, limit applied to this entire expression can be broken as limit applied to this expression multiplied by limit applied to this expression. Why? Because both these limits are existing. That is why limit of the product is product of the individual limits. See how intricate concepts are there which should be clear to move on from one step to the other step to get the correct answer. So here I am going to have limit x tends to 0 sine of pi by 6 sine of pi by 2 sine x whole upon pi by 6 sine of pi by 2 sine x multiplied by limit x approaches 0. Pi by 6 is just a constant, I can take it outside, and then you're left with sine of pi by 2 sine x whole upon pi by 2 sine x. Now over here see, as x is approaching to 0, this argument is approaching to 0, which is again sitting in the denominator as well. So this limit is going to be 1 by your very property. Even here if you see, this argument is approaching to 0, which is itself sitting in the denominator as well. So limit x tends to 0 of sine of this argument upon the same argument is again going to approach to 1. So if this limit is 1, pi by 6 of this limit will be pi by 6 into 1. So you get 1 into pi by 6 into 1, which gives you pi by 6 as the answer, which is there written as the third option, and so even this is correct. Moving on to the fourth option, it says, is there an x such that GOF of x is 1? So we have to verify whether GOF of x is 1 for any x or not. Let's see. So GOF of x, that means in place of x I am going to have fx over here in the expression of g of x. So GOF of x, which is g of f of x, is going to land to pi by 2 sine of f of x. Right? Now see, over here, suppose there exists some x in the collection of all reals such that GOF of x is 1. Just suppose it's true. Let's see if it is true or not. You all know that proceeding with contradiction by just an assumption is one very general way to approach to any question in mathematics. So that's what I am applying over here. Suppose there exists a real number for which GOF is 1. That means for this x, pi by 2 sine of f of x is 1. That means sine of f of x for this x is 2 by pi, right? So now fx was belonging to minus 1 by 2, 1 by 2. That's what was its range. So now minus 1 by 2, 1 by 2, of course they are real numbers, but if converted to radians to be actually framing in the form of argument, they are going to turn out to give you approximately minus pi by 6, pi by 6. So if fx is belonging here, this implies sine of fx belongs to minus 1 by 2 to 1 by 2. Why? Because it belongs to minus of sine of pi by 6, because sine of minus theta is minus sine theta, comma sine of pi by 6, which is minus 1 by 2, 1 by 2. That means for that particular x for which GOF of x was 1, for that x sine of fx is belonging in minus 1 by 2, 1 by 2 closed interval. But 2 by pi is what? It is saying sine of fx is 2 by pi for that x, but 2 by pi is approximately equal to 0.6. But sine of fx is belonging to just minus 0.5 to 0.5, and 0.6 does not lie in this interval. This means there does not exist any x for which GOF of x is 1. Understood? And therefore option number D stands to be drastically incorrect. Okay. That's how you proceed to attempt the questions, and as you can see, the concepts which I told you are important from this chapter happen to be all almost covered in this question. Moving on to the next one. We over here can see a question on definite integration. Let's see, what about definite integration? This is one chapter which is again highly important from your JEE Advanced perspective. You are definitely going to see a question from definite integration. If I talk about the important concepts, Leibniz rule is one highly important and crucial concept from this chapter. Reduction formula, properties of integral, two very important properties. One is the odd even and the other is x goes to a plus b minus x, that transformation, and limit as a sum. So limit as a sum is not that important a concept from JEE Advanced perspective. It was very important from JEE Main perspective. So we're left with three concepts: reduction formula, Leibniz rule, and the two hot properties about this particular chapter, that is properties of integrals. Right? If I talk about Leibniz rule, you can never in the history of JEE papers see any paper without this concept. It has to be there. So students who have not touched that topic, that is Leibniz rule, need to do it very thoroughly. The next thing which is utterly important and completely sure to be there in the paper is the property x goes to a plus b minus x. Whenever in any question you get stuck of definite integration, just apply this property, you will be halfway through to it. That's how important these properties are. Of course, you need to do all the properties. I'm not saying that just skip any property, but these two properties, the odd even one and this one, they are utterly important. Okay? Now, this question is giving you what? It is giving you in to be equal to this expression for n equals 0, 1, 2, 3 and so on, and which one of them is correct is what it is trying to ask. So, over here, if I try to see in is what? Minus pi to pi sin nx upon 1 plus pi to the power x into sin x dx. Right? Now see, over here if I try to apply the same property, that integral a to b fx dx is integral a to b f of a plus b minus x dx. Okay, the same property if I try to apply, which I am saying is very important, what is it that I am going to get? I will get that in will be equal to integral minus pi to pi sin n minus pi plus pi minus x, which is going to give you minus sin nx, whole upon, you will be having 1 plus pi to the power minus x again, which is 1 plus 1 upon pi to the power x, which will be 1 plus pi to the power x upon pi to the power x. So, pi to the power x I am going to send here, and here it will be 1 plus pi to the power x. Then sine of, again minus x, which is minus sin x. And this minus are going to get cancelled with each other. This is what is your in again for every n. So, adding 1 and 2, what is it that you get? You get twice of in. Twice of in will be, just add it up, sin nx is going to come out common. You will be left with 1 plus pi to the power x. Whole upon, you already have 1 plus pi to the power x into sin x. Again, odd even property popping up. You can see if you replace x by minus x, you can see sin nx upon sin x is an even function. And so this boils down to twice of 0 to pi sin nx upon sin x dx. That is what your twice of in is, which implies in is this. If in place of n you substitute 1, you are going to get I1 is what? I1 is what? Sin x upon sin x, which is integration of 1 from 0 to pi, which just gives you pi. And if you put n equals 2, that is going to give you sin 2x upon sin x, which is 2 sin x cos x. Sin x get cancelled. You are left with integration of cos x with 2 outside. Integration of cos x is what? Sin x from 0 to pi. Again, it gives you what? 0. So you have 2 into 0, that is 0. That is what you are actually getting. Now, option is saying whether In is equal to In plus 1 or not, and In is equal to In plus 2 or not. If fourth option would have been correct, I1 would have been equal to I2, but I1 is not equal to I2. That's wrong. We just need to check if In is equal to In plus 2 or not. So, talking about In equals In plus 2 or not, if I try to see In plus 2 minus In, so what was your In? This is your In. 0 to pi sin nx upon sin x dx. So In plus 2 will be what? Sin of n plus 2x minus sin nx whole upon sin x. Right? Now what is sin c minus sin d? It is what? 2 cos c plus d by 2 sin c minus d by 2, which is going to give you what? This is 0 to pi. So it will be 2 cos c plus d by 2 is going to give you this. Sin c minus d by 2 is going to give you this, which gets cancelled. And the answer to it will be 0 when you're going to integrate, which implies In plus 2 is equal to In. Right? Here it's trying to say when you add I to m plus 1 for m varying from 1 to 10, when you put m equals 1, you get I3. Now I1 is what? I1 is pi. And you know In is equal to In plus 2. So I1 is equal to I3 is equal to I5 is equal to I7 and so on. And I2 is equal to I4 is equal to I6 is equal to I8 and so on. That means all odd, whenever this is odd, you are going to get pi, and whenever it's even, you're going to get 0. So when you add pi 10 times, you get 10 pi. When you add 0 10 times, you get a 0. That's how the concepts are used over here in this case. Fine. Now let's move ahead and see what happens to be the next important concept. This particular question is dealing with the concept of limits. Again, if I talk about limits, there are some 4-5 concepts only which you need to master, and every question on limits in the paper will be there in your pocket. Like indeterminate forms, series expansion, L'Hopital rule, and limit as a sum. Again, limit as a sum is a JEE main, more importantly, concept. But if I talk about series expansion, indeterminate form, L'Hopital, they are really, really important. 2015 question was on L'Hopital. 2016 question was again on L'Hopital and limit as a sum. 2017, however, did not see a question explicitly on limits, but I cannot say that the paper is not going to have question or concept of limits. It is going to be there definitely, might in the form of limit chapter, or maybe they are going to incorporate it into application of derivative or integration in that sense, or differential equations. Right, but it has to be there. Okay. Over here, if I try to see limit x tends to 0, integration 0 to x square cos square t dt x sin x in the denominator, you can see if you plug in x equals 0, you are going to have 0 by 0 form. So limit x tends to 0. This integration sign is just in the numerator. You have cos square t dt upon x sin x. So here you can see it's 0 by 0 form, applying L'Hopital. Now for applying L'Hopital, the numerator needs to be differentiated. For that, Leibniz rule needs to be revised. What does it say? That if fx is equals to integration phi x to xi x ft dt, then f dash x is equal to what? F of xi x into xi dash x minus f of phi x into phi dash x. So when you are going to do that with the numerator, what is it that you are going to get? You will be getting what? Limit x tends to 0, differentiate the numerator, differentiate the denominator. That's what happens in the L'Hopital rule. What you get is cos square of x square into d by dx of x square, which is 2x, minus cos square of 0 into d by dx of 0, which is 0. So you get a 0. Denominator, simple product rule, use first term into differentiation of second term plus second term differentiation of the first term, which is 1. Over here, if you try to analyze, x can come out common. You will be left with cos square x square into 2 whole upon, again you can take out x common as it is approaching to 0 but not equal to 0. This will be cos x plus sin x by x. Right? Now as x approaches 0, cos x approaches 1. As x approaches 0, sin x by x approaches 1. We just revised that property on limits. So 1 plus 1 makes it 2 in the denominator. Right? If I talk about the numerator, cos square x square into 2. So as x approaches 0, x square approaches 0. Cos x approaches 1, its square also approaches 1. So you get 1 into 2, that is again 2. So the limit comes out to be 2 upon 2, that is 1. So if it's an integer type question, the very option which you are going to tick is 1. That means the bubble which you are going to darken is against the integer 1. So the answer comes out to be 1. Right? Just master those few concepts on limits and you are going to have the marks from this chapter. Moving on to the next question. Here you are given what? The function y equals fx is the solution of this differential equation, and then you have to answer what is the integration minus root 3 by 2 to root 3 by 2 of fx equal to. Okay. Talking about differential equations, there is one thing which is utmost important, and that is linear differential equations. A one-man army, I can say. I can vouch for this that you are definitely going to find a question on linear differential equations in your very paper. Okay, integrating factor is not at all a difficult concept to master. So if you have not done it, you have to do it at any cost. Okay. 2015, if I talk about differential equations, 2015 advanced paper saw concepts on linear differential equation and the formation of second order differential equations. 2016 saw concepts of linear differential equations and homogeneous differential equations. And 2017 saw concepts on variable separability. Okay. So you have to master the two concepts which are linear differential equations and homogeneous differential equations. Homogeneous is yet not that important as important it is to master linear differential equations. See, even if you have just done integration up to 12th standard level, not those of the advanced level, still you can master the very question of, or attempt and crack the question which is there in the paper from differential equations. So do it and score complete marks. This question again is trying to give you a linear differential equation, dy by dx plus py equals q, talking about its solution. Y, that is equals fx is the solution. How is the solution given? Y into integrating factor is equal to integration of q into integrating factor dx plus c. Now what is the integrating factor? E to the power integration of p dx is what is your integrating factor, which is e to the power integration. P is what? X upon x square minus 1. dx. Now see, separately if I try to show you, you can apply partial, this partial fraction technique. It will be a upon x plus 1 dx plus integration b upon x minus 1 dx. Very easily you can see you are going to get a equals half and b equals half, and therefore integration of x upon x square minus 1 will be integration of 1 by 2 of x plus 1, which is 1 by 2 ln x plus 1, plus again 1 by 2 ln x minus 1, which is going to give you 1 by 2 ln of x plus 1 into x minus 1, which is x square minus 1, and inside the mod sign I can also write it as 1 minus x square. And by the property of log, I know this is ln root over 1 minus x square, because 1 by 2 is going to go above as the power and you are going to get this. Therefore, what is this equal to? This is equal to e to the power ln under root of 1 minus x square, which is under root 1 minus x square. That's your integrating factor. And therefore, your very solution becomes what? Y is fx into under root 1 minus x square is equal to integration of q. Q is what? Q is x to the power 4 plus 2x upon under root 1 minus x square. So it is x to the power 4 plus 2x upon under root 1 minus x square into under root 1 minus x square dx plus c. Obviously this gets cancelled. You are left with x to the power 5 by 5 plus 2 into x square by 2, which is just x square plus c. Now you are already given that f of 0 is 0. So when x is 0, fx is 0. When you plug in x equals 0, your fx is 0, you get 0, 0, 0. That means c comes out to be 0. Therefore, fx is what? Fx is x to the power 5 upon 5 into under root 1 minus x square plus x square upon under root 1 minus x square. Therefore, integration from minus root 3 by 2 to root 3 by 2 fx dx turns out to be integration from minus root 3 by 2 to root 3 by 2 x to the power 5 upon 5 into under root 1 minus x square dx plus integration minus root 3 by 2 root 3 by 2 x square upon under root 1 minus x square dx. Now carefully analyze when you are going to substitute x equals minus x over here. This is going to come out to be an odd function, and therefore the answer to it will be 0. Whereas if you plug in the value of x as minus x, this is going to come out to be an even function, and you will have twice of 0 to root 3 by 2 of this expression coming up as the next step. So you have your fx equals to twice of 0 to root 3 by 2 x square upon under root 1 minus x square dx. How to integrate? Well, for this basic integration techniques you should definitely be aware about. Let x be equal sine theta. This implies dx equals cos theta d theta. And if x is 0, sine 0 is 0, or I should say if x is 0, sine inverse x is 0, so theta is 0. And if x is root 3 by 2, sine inverse root 3 by 2, that is pi by 3, so theta is pi by 3. So you get twice of 0 to pi by 3 sine square theta upon under root 1 minus sine square theta, which is cos square theta with the under root sign, that means cos theta, into cos theta d theta. Now sine square theta you can write alternatively as 1 minus cos 2 theta, because you can see there is 2 sine square theta from 0 to pi by 3. And this eventually, when you integrate, you are going to get theta over here, and you are going to get sine 2 theta by 2 over here. When you plug in the value of theta equals pi by 3, what is it that you are going to get is pi by 3 minus root 3 by 4, which happens to be your B option. Understood? That's how linear differential equation happens to be utmost important concept for your JEE Advanced from this particular chapter. See, do not go by the weightage of the chapter. If you go by the weightage of the chapter, you see differential equations weightage is this much, you're going to sit and start preparing the entire chapter. Go by the weightage of the topics which are really important, and therefore you're going to save a lot of time and you are going to, improve your efficiency towards the topics which are really important and are bound to come in your paper. Okay, so do not go by the weightage of the chapters, go by the weightage of the topics. Moving on to the next question, last question talks about the concept that is area under curves. It is saying fine, let fx be equal to maximum of these three functions, determine the required area. Now talking about area under curves, I personally feel area under curves is not a chapter which is more about integration or application of integration. It's in fact more about curve tracing, it's about graphical transformations, it's about shifting of the origin. You have to be thorough with the concept of graph tracing and graphical transformations. If you are not at all master of this area, you cannot focus marks or you cannot gather marks from this chapter. You have to have the grip upon the graphical transformations and curve tracing, okay, to have marks obtained from this chapter. Talking about 2015, there was no question asked from area under curves, but 2016 had questions involving line and dual parabola. So as it is advanced, it's not main. That is why you might not actually directly get a question to compute area. It might require a little extra effort from your side to see what the question is trying to ask. The dual parabola's equation in that case was given in the form of mod, and that one equation was giving rise to two parabolas. So until and unless you have that extra thought plug in that particular question, you cannot get what that question is trying to convey. Again, 2017, I would say, saw question on line and cubic equation. Okay? So this chapter holds to be very, very important, but only when you are thorough and a master of the graphical transformations and curve tracing. Okay? There is a very famous book which even I have and I still read through it, which is Playing with Graphs by Amit M. Agarwal. It's such a playful book. Whenever you are sitting, chatting, or maybe lying on the bed, not about to sleep, just open that book and start reading. When you're undergoing a journey or in the train or a bus, just open that book and start reading. It's like that. You are never ever going to get bored reading or going through that book, and it is a must-have. Okay? Now this question tries to give you the definition of the function f, which is maximum of these three parabolas, and only when x is ranging from 0 to 1. So over here, if I try to tell you what the curve would be, for that you should be aware about the three curves given in the question. First is talking about y equals x square. Okay. Next is talking about y equals 1 minus x whole square, which is this. This is your 1, 0, and this point is 0, 1. And third is 2x minus 2x square, which is this. This is 0, 0 obviously. This is 1, 0, and this is 1 by 2, 1 by 2. So when all these three are graphed together just in the range 0 to 1, what you get is, this is y equals x square. I'm just plotting the magnified range. Okay. Then this is your, this one, which is 1 minus x whole square, and then you have this one, which is what? 2x minus 2x square. Okay, so this point somewhere here would be half, half. This is 1, 0, and this is 0, 1. it's very, very easy to compute what is this and this point. Why? Because if you are going to try to find out the point of intersection of this curve and this curve, that means y equals x square and this one, which is 2x minus 2x square. When you're going to write it as x square equals 2x minus 2x square, you are going to get x equals 0, 2 by 3. That means this point that you can see is 2 by 3. Similarly, this point is actually the point of intersection between y equals 2x minus 2x square and 1 minus x whole square. Following the exact same lines, when you're going to see, you are going to find x coming out to be 1 and 1 by 3. So 1 is obviously here, so this is 1 by 3. That means if I talk about fx, from 0 to 1 by 3, fx is maximum of all these three curves, and maximum is nothing but this. The highest of all three curves from 0 to 1 by 3. From 1 by 3 to 2 by 3, maximum is this, which is 2x minus 2x square. From 2 by 3 to 1, this is the maximum, which is y equals x square. So this happens to be the graph of f in 0 to 1 range. What did I say? That fx is equal to what? It is equal to, which one is this curve? 1 minus x whole square when x ranges from 0 to 1 by 3. Then it is equal to 2x minus 2x square when x ranges from 1 by 3 to 2 by 3. And it is equals to x square when x ranges from 2 by 3 to 1. Therefore, integration of fx dx from 0 to 1 is integration of 1 minus x whole square dx from 0 to 1 by 3 plus integration of 2x minus 2x square dx from 1 by 3 to 2 by 3, and from 2 by 3 to 1 you have x square dx. You are just being asked to integrate quadratic equations over here, which is a child's play. You can do that. You are going to get your answer as 17 by 27 square units. Okay, and that happens to be the answer for this particular question. Okay, so here we discussed 5 chapters, or basically 5 questions, making you realize that these 5 chapters are really, really important and a must do for your JEE Advanced preparation. See, questions can never be repeated. It's JEE Advanced, highly unpredictable paper. That too, it's happening online this time. But what can be same is the concept and the type of questions which are mainly asked. Okay, so stress upon that. You can even have questions more than one from one particular chapter, and that is why I have specified all the important concepts which you need to do from a particular chapter. Here I have just covered one question, but it doesn't mean this question itself is going to come and pop up in the paper. The concepts which I have told you and shared with you are really important, and your entire paper from these 5 chapters is going to be circulated and completely from these concepts itself. So master them. All the very, very best for your paper. Do well. All the best. Thank you.